All right, for today, we hopefully will finish the topic about object equality, and then I'm really hoping to get to a small topic called call by value. That's also very important for your understanding for many things. And then we'll talk about aggregation and composition next Tuesday. I'm pretty confident I can finish that. And then next Thursday, inheritance. All right, so that'll be the plan. And let's see, basically not too many reminders, pretty much the same as Tuesday. So please make sure you submit your lab number 2 in time to claim your credits. It's going to be 12 noon tomorrow. I'll try to send you a reminder a little bit later today. And then I'm going to release your lab number 3 tomorrow after the lab 2 deadline. Lab number 3 is going to be a relatively shorter lab for you to work on. So it will only be 1 week necessary. We're going to save a little bit more time for lab number 4 and 5. I think those 2 labs, you can expect more struggle, but at the same time, more learning to be done for lab number 4 and 5. Okay. For your programming test number 2, you'll be next Wednesday during your lab session. So my only tip for you for programming test 2 is make sure you can do practice test 1. Make sure you can do it, and then review the documents that I released for, preparing for lab number for programming test 1, and make sure you know how to do exceptions. So I think the best preparation is redo lab number 2. Right? I already released a video solution to you. You can feel free to go over it together with me on the video and reach out to me if you got any question. I'll try to see if I can schedule some additional hours just for you guys, maybe Monday or Tuesday, so you can still come to me if you got questions. I'll try. I don't think a review Zoom session will be necessary this time because we don't really have a new problem to work on. But I'll try to make some hours for you. Well, I'll reach out to you about it. All right, guys, any question about the course before we talk about some technical stuff? All right, if everything's good, why don't we get started? All right, so let's now do some very important recap from last time, and then we'll continue from there. So basically, last time, I think we were picking up from where we left off from reading week. We talked about the overridden version for the equals method, right? And then especially, we'll talk about phase number 4 over here. And in order to understand this particular chunk of code, we have to make sure we understand what getClass method really does. That one is going to retrieve the dynamic type for your objects, right? That's what we said about. And please make sure you go over that exercise again, which we did thoroughly before the reading week, about static type, dynamic type, and typecasting. It is important for you to understand the concept there. And we talk about this guy over here, right? To say why you would need a cast from objects into this particular type. It's important for you to review that. And we did examples, as always. Right? You can review the example and let me know. And I keep emphasizing, but I'm pretty sure I'll do that again many times. Whenever you have a method call, not just for equals method, as we'll see for later, but for now, just focus on equals method. Which version of the equals method are we going to call? It depends on the dynamic type of the context object. In this case, if P1 is pointing to dynamically point V2, that means we're going to call the version of the equals method from that class, which will be overridden. All right? And I believe the homework or the study I wish you will complete before today, that one also has some example there. But I'm going to go over it with you as well, right? Just to make sure. Always repetition is nice. Right? Just remember that rule. It's really important. And then we spoke about basically more example about non-overridden versus overridden. And we talk about object equality versus reference equality, right? We said there's a logical relationship between them using implication. We also talked about it in detail last time. Make sure you also go over them. And that's one of the requirements for equals method, to say whenever you want to compare an object equals to some null value, it should never be true. It should always be false. All right, and then we did more example about the JUnit assertion. Assert the same. Very straightforward. You just compare equals always for reference equality. And for assert equals, it really depends on the types of expressions we are talking about. If the 2 expressions over here are simply primitive type, like an integer, In that case, it would be as if we did equals equals between the primitive value. That one's straightforward. The more complicated scenario comes in if we have to do reference type. Let's say expression 1, expression 2. I think I did some summary notes over here for you. All right, that one's really important. The order of the arguments to the assert equals assertion really matters. When you put expression 1 first, that means it would be as if you're invoking the equals method on expression 1, in which case the dynamic type for expression 1 is going to determine which version of the equals method that will be invoked. On the other hand, if you now try to put expression 2 first, in that way, it would be as if you said expression 2 dot equals. Now, expression 1 is no longer important. What's really important to determine the version of equals to be called will be the dynamic type for expression 2. Right? So that's really important for you to also understand. I would say at this point, maybe it might be easy for you to forget about the rules. That's normal. But as we keep emphasizing in the lecture, as you do more and more example and practices, these should be very natural to you. All right? Hopefully by the end of the course, or at least before the exam. Right? I'm pretty sure I'll ask you some question about it later. So it will take some time to digest. And of course, your last resort is to memorize the rule. It's not going to last for long. I really want you to really understand the logic behind these rules so you can really stay beyond this course. I think that's important. All right, so the last thing that we spoke about is the logical operators that you learned from the first year, literally, namely, ampersand, and vertical bar, vertical bar. And I would like to maybe repeat some points, maybe a little bit later today when I revisit the example relevant to it. But I'll go back there a little bit later. Okay, so there was something I talked about a short circuit evaluation. I'll repeat that a little bit today. So let's now recap from now. All right, so that's about what we spoke about on Tuesday. Any question? Any points you think is really, really confusing? You want me to repeat right now before I move on? All right, that's good. Why don't we do more examples on the G-unit assertion? I think you guys deserve a little bit more repetition before you can really get some sense out of this stuff. I'll get to the short circuit evaluation a little bit later, but I would suggest we start with some example. Okay, this will be the last one. Sorry, not really the last one, but it will be the last easy one to trace. Because after this one here, I'd like to do another example for equals method that's going to involve array. All right, but let's do this one first as a warm-up. All right, let's now take a look. So for the example here, part 1, we are considering point V1. If you recall, point V1 does not have the overridden version of the equals method, right? So we got an object version to be called. This one easy, but let's do it. So this will be the J-unit test assertion that we want to really get through. And by the way, the example code of this is also on the lecture site. Do download it, play with it, run debugger if necessary, just play with it. That's the shortest way, I would say, to really learn about it. Okay, let's now do this one here. So we got P1 and also we got P2, two objects here. So for P1 is 3 and 4. For P2 is also 3 and 4, but they're different objects. And if you do P1 equals P2, obviously it should be false. That's why when you say assert false, it's going to pass. I'll just say P here, so you know what I meant, pass. And if you say P2 equals P1, doesn't matter the order. In this way, it's also going to be false, so assert false is also going to pass. Again, it don't really say if an assertion is true or false. Either pass or fail. Sometimes you might try to assert some expression that's expected to be false. Sometimes you might want to assert some expression that's expected to be true. So it depends, right? And since we are comparing references over here, you can also try assert the same. Either P1 followed by P2 or P2 followed by P1. Doesn't matter. Because in this case, they're different objects. So both assertion here will simply just fail. Not just false, it will fail. All right? And let's now try to do equals. You can see I intentionally try two things over here. I got P1.equals, where P1 is the context objects. I also got P2.equals over here. right? The context objects. Now, are they going to call the same version of the equals method, even though I got two different context objects? They are. The reason is P1 and P2, they are dynamically pointing to point V1 here and also point V1 here as well, right? So these two dynamic types determine which version that's going to be invoked. So what I would do is I'm just going to make some indication here. You can see this one tells you P1 dynamically is point V1. And this one tells you P2 dynamically is point V1 as well. So the same version of the equals method will be called. But don't assume it. Sometimes it might be different, right? Which we'll see in the later phase of the example. All right, so after analyzing this, now it should be very clear to us to see the result. So now the equals method is going to be the default version. So this will simply boils down into P1 equals P2. And this one here will also boil down into the default version, which will be P2 equals P1. Right, so both of them is going to return false. So that's why assert false will pass. All right. Yeah, and if you want to just compare the content, so far at this point, we don't have any overridden version of the equals method. So if I really want to compare P1.x, P2.x, the only way I can do it is by writing this out. All right? That's just another example here. All right, that's phase number one for the example. Any question? Okay, should be quite good. Let's now move on to the second part. All right, let's now move to the context where we got our overridden version for point V2. So whenever the context object has the dynamic type, for example, here point V2 and point V2, we are going to invoke this version only. This version here will be irrelevant. All right? Let's now take a look. Let's say we got P3 over here. That one has 3 and 4. We also got P4 over here. That one there also got 3 and 4. All right? Now, P3 equals P4, for sure, it's going to be false. And P4 equals P3 also is going to be false. Very easy to see. And accordingly, if you try to assert the same, P3, P4, or assert the same, P4, P3, both of them are going to fail. Different objects, right? So far, we haven't touched the equals just yet. Right? And let's now move on to the next two lines. Here, P3. Here, P4. The context objects, right? Different. Again, you want to refer to the dynamic types for P3 and P4. So now in this case, for P3, the dynamic type is over here. For P4, the dynamic type is here. They happen to be the same. Again, they don't have to be the same, right? Which we'll see in later part. So that means in this case, we're going to invoke the default version of the equals over here. And for this one here, we're also going to invoke the default version over here. And for the tracing, I'm going to leave it to you because we have done that so many times. And for this one here, P3 and P4, you can see the contents are just the same, even though they are different objects, right? So it's going to return true. Okay? And P4, P3, also, even though they are different objects, but they are the same. Content-wise, also true. All right, and then if you try also assert equals. And notice one thing here. I'm just trying to show you the equivalent way of doing things. If you think about number 1 here and number 2 here, they're really doing the same thing. For number 1 here, I'm saying assert true, and then P3 dot equals P4. Versus in number 2, I say assert equals. And then P3, P4. They are really the same thing, really. Okay? The only difference is I'm using 2 different assertions. One is this one here, and one is this one here. You can say that doing this is as if you wrote something like this. Of course, assert true is more general assertion. You can put any expression you like. That's going to return true. right? But I'm just showing you that equal. All right, any question about this part here? Also very straightforward. The only difference is we are calling a different version of the equals. All right, if we move on, the next, the next logical step is to see what if the context object and the arguments have different dynamic types. How are we going to deal with it? All right, now it will be important. So now we're going to put the two classes into the context. We have point V1 without any overridden equals. We got point V2 that has the overridden equals. All right? So now we have to see very clearly about the dynamic type for the context objects because it can be either point V1 or point V2. And the equals method to be called accordingly would be different. Okay, okay, let's now go over them. Let's start by using, P1. So P1 over here is going to be 3, 4. 3, 4. As you can see, dynamic type for P1 is this. All right, point V1. On the other hand, we're going to have, let's say, P2. P2, we got 3 and 4. 3 and 4. However, it has a different dynamic type, even though X and Y are the same. All right? So this one here, point V2, you can see the dynamic type is different. Okay, I'll put here dynamic type, and here, that would be the dynamic type, right? You can see very clearly where things come from. Now, I do have some highlights over here. Let me use a different color here, otherwise it might be confused with the orange. I want you to look at these two. I'll make it a little bit larger just in a moment. I want to box them first. Okay, if you can please look at this one here and this one over here. All right, now let's say the first one here. Is it going to pass or fail? Or something else? Does not compile. That could be one option. Anybody else? Okay, so since I've got three options here. Pass, fail, or does not compile. Anyone? Sama, why would you think that doesn't compile?
Because there are different classes.
There are different types over here. You cannot really compare orange with apple directly, right? Explicitly. That's good. So if you guys try this one here to write down P1 equals P2, explicitly, it's not going to compile. All right, so not going to compile. And it's not going to compile because you can see for P1 and P2, point V1 versus point V2. You cannot compare two variables of different types directly. You just cannot. All right, so that's not compiling. On the other hand, if you try these two, assert the same, and then I put P1, P2, and P2, P1, all right? Now, for the first one here, it would be as if, implicitly, I'll put in quotes, P1 equals P2. You don't really write it explicitly, but that's something behind the scene Java runtime will do for you, so that's okay. So this one here compiles. Whenever you're trying to write an assertion, assert the same, this first expression and this second expression here can be anything, just any objects, including if they are different types. That's okay. So there's a critical difference here you want to see, right? If you want to compare two things of different types explicitly by yourself, no, it doesn't compile. But if you write assertion like assert the same, assert equals, whatever, it might boil down into comparing two different things. But that's okay. It's not your responsibility. Right? So there'll be no compilation error. All right, so let's now move on. What about this guy here? P1 dot equals P2, P2 dot equals P1. All right. Let's now be very critical here. Let's say P1 over here. P1 context objects star. And also P2, I use orange, so let me be consistent. So P2 over here, star, star, right? So let's now write down what we need to know. So for star, the dynamic type of the context objects is point V1, exactly here. That tells me the default version of the equals method from object class is going to be called, because there's no such methods overridden in the point V1 class. On the other hand, when I talk about star star over here, the dynamic type is different. Of the context object is now point V2. Because you can see P2 indeed has dynamic type point V2. That tells you it's going to invoke this version of the equals method instead, right? Be very clear about which version is going to be invoked. This will be star, and this will be star star. All right? And let's now try to see what's going to happen here. If we try, how about this? Just by looking, I'll try to make it as much as possible, okay? I want you guys to think about it for one moment. Let me tell you something to begin with. I say P1 dot equals P2, I can tell you that this is going to return false. I'll tell you first. That's why assert false is going to pass. P2 dot equals P1 is also going to return false. That's why assert false will also pass. Now, here is my question to you. Is this assertion, does this assertion pass for the same reason as this assertion passes? I'll write down the question, but I want you to think about. The question is going to be about this, right? So question, do these two assertions pass for the same reason? I can tell you that it shouldn't in some way, because I already told you P1 here is going to invoke this version, and P2 over here is going to invoke this version. All right, so now I'll pause for 1 minute. This is what I expect to hear from you. Tell me for exactly what reason number 1 is going to pass, and for what reason number 2 is also going to pass. Number 1 here and number 2 here. Okay? Pause for 1 minute. Think about it. This is critical. Okay, just one more moment. Okay, for number 1. When I say P1 dot equals P2, why does it evaluate to false so that assert false pass? Robert, go with you first.
Because when you're calling the non-overridden equals, it's the same thing as we just talked about.
Yeah.
Different types.
Yeah, different objects basically, right? Okay, that one's easy, but let's be sure by writing it down. So for star over here is basically going to boil down into P1 equals P2. And of course, it's going to be false because they're different objects. Okay? That's why number 1 should evaluate to false. So making assert false pass. What about number 2 here? That also evaluate to false for this expression here. But why is that? Tell me why and exactly which line determines we should return false from that dot equals method. Yeah. Go to this one here, right? Mm-hmm. 1, 2, 3. Mm-hmm. Yeah, That's pretty precise. Thank you. Yeah, let me just repeat your point if I may. So here for star star over here, we know that we're going to execute the equals method from point V2. And then as we're executing it, just don't forget we got P2 being the context objects. When we get to this point over here, P2 will be here. And also OBJ will be here. Right? P2 that, yeah, exactly. P2 that equals P1, just be sure. So now, what about P2 that get class? P2 that get class is going to give you point V2. P1 that get class is going to give you point V1. They are not equal to each other. They are different dynamic types. So that's why this not equal to is going to evaluate to true. So you will execute the body of the if branch, which is going to return false. So that's the reason. So you can see both P1 that equals P2 and P2 that equals P1 both evaluate to false, but for different reasons. Different part of the code is being executed. That's the main message you want to get. All right? How do we know? Because the dynamic type for the context object is different. All right? All right, any question here about this? Yes? Yeah. Mm-hmm.
The parameter obj, it's object.
Mm-hmm.
Why doesn't obj.getClass return object?
Because, okay, that's a good question here, fair one. The question was, here, okay, first of all, you can see P1 currently is pointing to point V1. That one we agree, okay? And now, if you look at the declaration here, objects over here is declared to be objects. That means its static type is objects, all right? But when we say P1 that get class, we're asking for dynamic type, not static type. So what you said would be objects over here is not right because static type doesn't determine what the get class will return, only the dynamic types. In this case, P1 that get class is going to search through. P1 is actually going to go to this particular object here, and then it's pointing to P1, point V1 objects. That's why. Okay?
So even if like the static type is object?
Doesn't matter. So get class, easy. Get class, simply return the dynamic type. Doesn't matter what the static type is. Yeah, good. That's a good question. Yes? In which case is it going to be true? Well, we're going to see something. In this case, I can tell you it should not be true because P1 and P2, yes, we can see that 3,4 and 3,4. It's more like an apple and banana. They do share some attributes in common, but you cannot say apple is equal to banana, right? So it doesn't matter how this method should be defined or how this method is defined. Since you're comparing two objects simply dynamically of different types, they should never be equal to each other. So that should be false. Yeah. Think about equality goes like this. You should only compare two things if they are of the same types. If they are simply of different types, it doesn't matter if they share some attributes in common. They should just be unequal by definition. Mm-hmm. Alrighty. And the last phase for the example will be very similar. Okay. Oh, is this the last one? Okay, that's the last one, it seems like. Okay, good. I think that's it. Okay, good. Right, so this will be the last phase for the exercise. So guys, one more thing to say before we move on to something else. You really want to convince yourself these two are really calling different versions of the equals method, even though they both evaluate to false, right? That'll be the final message. All right, if no more questions, I think we should move on. And that's something to do with some more equals example. But I would suggest before we do that, I will go back to the short circuit evaluation. Let's switch the context slightly. Because in order to carry on with this discussion for the next equals example, we need to be sure you understand what short circuit evaluation is. Okay, I did say something in principle on Tuesday already, but let me just repeat that slightly, more briefly. Okay. So we talk about two logical operators in Java. We got ampersand, ampersand, and that one, of course, is called conjunction. Logical conjunction. And for or, vertical bar is for disjunction, or. And this is how short circuit evaluation will work. At a runtime, if you got two expressions, let's say expression 1 and expression 2. Number 1, the order of evaluation is going to go from left to right. That will be the evaluation. You always try to evaluate the left-hand side, expression 1. And you might determine that evaluating expression 2 is not necessary, so you just skip it. All right? So now there are two cases over here. Case number 1, if expression number 1 evaluate to be true. In that way, you also want to evaluate expression 2 to determine. So this really corresponds to these two lines over here. Because once you know that expression number 1 is actually true, what expression number 2 is determines what the final result is. So you still want to evaluate logically. All right? And number 2, case number 2. Let's say expression number 1 evaluate to be false. Right? In that way, it will correspond to these two lines over here. Right? As you can see, if expression 1 is already false, it doesn't really matter what expression 2 is, either true or false, doesn't matter. The final result will just be false. So what's going to happen is we're going to skip the evaluation of expression 2. And then, most importantly, which I didn't quite mention on Tuesday, in this case, the ampersand evaluation is going to be false, which we'll see. Right? In this case, it will be false, and then we also skip the evaluation for expression 2. All right? And let's now do some very quick recap to see the symmetry in the disjunction. So for disjunction, so let's say here, okay, so we are also trying to evaluate, let's say, expression 1 or expression 2. And then the order of evaluation is also going to be from left to right. All right? And then two cases. Case number 1. Let's say expression number 1 on the left somehow evaluate to true. And, oh, sorry, I really meant to say by symmetry, right? I should really say false to begin with. Let's say that's false. And then it really corresponds to these two lines. Line number 1 and also line number 2, these two lines. As you can see for these two lines, the left-hand side is simply false, in which case, depends on what the second argument is, like expression 2. If expression 2 is false, the final result will be false. If expression 2 is true, the final result will be true. So we do have to evaluate expression 2. All right? And then here we still have to evaluate expression 2 to decide. All right, for number 2, which I'm going to use a different color. Okay, for number 2, let's say when we evaluate expression number 1 on the left, it turns out to be true. All right? And this will correspond to the remaining two rows. Row number 2 here, and also row number 4 over here. And you can see for these two, true and true for expression 1. In that case, it doesn't really matter what expression 2 is. The final result will just be true. So we don't need to evaluate expression 2 anymore. So we can skip the evaluation of expression 2. And then what will be the final result for the vertical bar in this case? Should be true, right? Because we already know one of the operand is already true. Now in this case, the vertical bar will just be true. This is a very important reasoning to understand the short circuit evaluation. So the case where you want to skip the right-hand side operand is kind of different between conjunction and disjunction. You can see. But we're going to see some example to see how useful this might be. So the short circuit evaluation really has its value in the programming context because you know that you're going to evaluate from left to right. Maybe sometimes the right-hand side expression is certain expression that you're worried that it might crash. So if I can take advantage of the fact that this possibly crashing expression can be avoided if there are certain conditions that's not met. That's kind of conceptual idea, right? But let's see exactly what I meant. The simplest example to illustrate will be like this. Let's say we want to, let's see, oh, it's exactly here. Let's see the case for conjunction. Let's say I want to evaluate y divided by x. Okay, y divided by x. How can this expression crash? Well, if x is equal to 0, division by 0. You agree? So in order to protect this particular expression over here, what I would do is I'm going to say I'll put this on the right-hand side of the conjunction. And I will only go ahead to evaluate this one here, given that this is true. That's exactly exploiting the power of short circuit evaluation. I'm saying that if x is not equal to 0, which is going to make this true. And then, according to the rule for short circuit evaluation, I'm also going to evaluate this, which is okay. On the other hand, if x happen to be 0, in that way, x not equal to 0 is going to be false. In that way, based on this second rule, I'm not going to even bother evaluating this. So at the runtime, I'm saving some crash possibility. All right? Let's just trace this one more time, just to be sure. Let's say we want to trace this guy here. This one here. Let's say now x is 0 and y is 10. So let's say x is 0 and y is 10. Okay? So what we have, this guy here, is like this. We say that 0 not equal to 0. And y will be 10 divided by 0 larger than 2. That's conceptually, right? And now at the runtime, how is Java going to evaluate this? Okay? Number one, when it sees this expression over here, it sees that it is actually false already. Now, are we going to evaluate further? No. So what it's going to do is it's going to say, I'm not going to evaluate this because if I do, I'm going to crash, division by 0. So what's going to do is it's going to skip this one here. And then overall, the conjunction is going to be false. All right, so this is one example where you use the short circuit evaluation properly. All right, but I'm going to show you one where it's not proper. All right. Let's go over one more example here, but you can also do the second trace as exercise. All right, I'll leave that to you. This one here. All right. For the second one here, let's say we still want to do division by division. Let's say we want to maybe protect y divided by x over here. And let's say we still got, let's say, x equal to 0 and y equals to 10. Let's say we have that. Okay. Over here. There we go. So x will be 0 and y will be 10. And now, in this case, if I try this expression here, 0 equals 0 because x is equal to 0, or 10 divided by 0 larger than 2, right? I still got the possibility of running into division by 0. However, now, when I evaluate this, it should be true. Based on this rule, if that's already true, I don't evaluate the right-hand side. So now this part over here is going to be skipped. And then the overall result for the disjunction is going to be true. Right? That's when things work. So now, how can things not to work if you use the short circuit evaluation improperly? It's when you put the order of the expressions wrongly. Okay? So this is the principle, and then we'll just see one error. Okay? Here is the principle. So to really make use of short circuit evaluation, This is the general principle. So number one, case number one, if you try expression 1 and expression 2, all right? So you can think about expression 2 is some expression we want to protect. Some parts needs to be protected. For example, if you got division, or a very typical thing to have is array indexing, especially for I index. I should be, for example, larger than or equal to 0, and also less than the length of the array, right? That one I can maybe give you more example, maybe another day. But for now, let's focus on division. And what you want to do is, for expression 1 over here, is something called the guarding condition. It's protecting. If the guarding condition is true, that means this is safe to evaluate. If the guarding condition is false, that means we should really stop evaluating this and just return false for the conjunction. All right? Similarly, you can do for disjunction. So now expression 1 and, or expression 2. And expression 2 is also something we would like to protect, right? The same. But now I will call this expression 1 here a little bit different. Rather than guarding condition, let's say error condition or problematic condition, doesn't matter. Let's say error condition. For example, we said before x equals 0. Let's say we want to protect y divided by x, right? It would be considered an error if x happened to be 0. In that case, if the error condition is true, in that way, we don't want to evaluate this. In that way, this might just return true. We safely avoid evaluating this. On the other hand, if the error condition here is actually false, in that way, x is not equal to 0. In that way, we can still evaluate this. Okay? It really follows the same principle. So I would say go over these two principles here and look at the example there. So that should be clear. Any question? Okay, I have a question for you. And think about that. Let's say I have exercise, 2 of them, number 1 and number 2. Let's say the expression I would like to protect is a at index I, assuming that I is somewhere, declared somewhere. AI is larger than 0. I want to make sure the number stored at index I in array A should be positive. Now, I want you to do the following. I got conjunction here. Disjunction here. Conjunction. There we go. All right, I want you to fill it out. Number 1, or maybe A, B, C, D. A, B, C, and D. A, B, C, D should be filled out in a way that's going to protect the array indexing. That'll be your exercise. All right? If you want to check the answer, discuss with your classmate to make sure you agree, or you can come to me. All right? I would suggest you try it and do it. Okay, one more thing I would like to do here. What about common error? Now, I'll just talk about one of them. Now, I want you to take a look at this. This one here is also using conjunction, which, of course, is going to have short circuit evaluation. But is this actually appropriate? If you don't think that's appropriate, can you describe to me what can be problematic? Robert? The order is wrong? Tell me how exactly it can go wrong.
Okay, so the guarding condition is supposed to be that x doesn't equal 0.
Yes?
But it's going to evaluate the y divided by x first.
First.
Which could crash.
Exactly. That's exactly right. So now let's see this. So that's why we said programming is not exactly equivalent to logic. Logically speaking, P and Q, Q and P, they are the same. In Java, expression 1 and expression 2 versus expression 2 and expression 1, they are different. All right, just for this particular one, if you try this, x equal to 0 and y equals 10. All right? So now we are simply just going to evaluate this one first. So we're going to evaluate 10 divided by 0 larger than 2. And it's too bad. It crashed right away, even before you can reach the guarding condition over here. Guarding condition evaluated too late. Will not even be reached. And we know that this one over here that's going to be evaluated first is going to crash. Division by 0. All right? And you can do the similar verification over here. I'll leave that to you. All right? This one is also wrong. Just the order is not right. Because now you're putting the error condition later, not first. That's what I want to talk about short circuit evaluation. And we can see some application right away, also in the equals method. All right? We're going to see that. Any question about the short circuit evaluation? If you kind of know this from the first year, very good. It's a good brush up. If no, learn it now. It's important. All right. Let's now consider back to the equals method, and we're going to see one more example. Over here. There we go. Okay, if you go back to the slides, I would like to consider this one here. So this one, we just go slightly more complicated rather than just x and y being integer. Why don't we make it slightly more interesting? Let's say we have a person class, and we got string attributes, like a reference type. We got first name and last name, and we got the weights and the heights. All right, so 4 attributes. And what we want to, well, usually you will be given as instruction to say in English, to say, now I say 2 persons are equal if their names and their weight and height measures are equal. Basically, I want to compare all these 4 attributes to make sure they're equal. But I want to be careful, because for the string over here, it's reference type. So you cannot just compare equal, equal. Not necessarily, because they might be different objects, but the same contents for the string. So you want to make sure you use the equals method. On the other hand, for the weights and heights, they are simply double. So they are primitive. So you definitely can use equal, equal. So you got to be very careful about what kind of comparison mechanism you use. All right, so for this one, it's pretty straightforward. I'm going to show you the answer right away, and then I'm going to ask you some question for a little bit discussion. So let's say we got our equals method here. Standard for the 1, 2, 3. Okay, actually for number 2 here. I want you to take a look here. This guy here is basically a slight simplification. I'll show you what I meant. If you look at the first 2 cases here, so there are 2 possible cases where I can return. Let me just make sure I just be consistent. Yep. So there are 2 possible ways for me to return false ultimately. Either it's because the object is equal to null, or it's because this is not equal to objects. Right? Oh, beg your pardon. I really meant to say this. Let me be very precise, otherwise I don't want to confuse you anyway. What I really meant to say is this. Let me put it here. Right here. What I want to combine are these 2 cases. Case number 1 and case number 2. Again, sorry for the confusion. You can see for these 2 cases, both of them return false. So now I want to combine them together to say either condition 1 is true or condition 2 is true. I will return false. So the way I write it is like this. So can I just say this condition here is number 1. This condition here is number 2. So now I got 2 options. Either I can say if number 1 or number 2. And then I return false. So let's say this is A and B. If number 2 or number 1 return false. A or B? That's the question. Or both. Which one is going to work and which one may not work? Or both work? Well, none of them works. Anybody? I'll hold for a moment. Yeah? You guys know what the question is, right? Okay, I'm basically trying to make my code slightly simpler, slightly, by combining cases. Okay, please go ahead. You think A should be good? Okay, how about I ask you the other way? Why would you think B doesn't work?
If object is null, we'll get a null pointer exception.
Right away, without being able to check the guarding condition first. Okay, that's very nice. All right, guys, so now if you take a look at this, if you look at B, so B should be okay, and A should not be okay. And if you look at that, we're going to check to see over here, number 2, one of them, part of it is to call obj.getClass. And then for number 1 over here, it's going to check to see obj equals null. Apparently, this is the error condition. However, are we going to evaluate this one first or this one first? The left, unfortunately, because evaluation always goes from left to right. So this is going to be evaluated first, but now if obj happen to be null, you get null pointer exception. But if you swap the order, like in A over here, in that way, you're actually going to work. In that way, you're going to check this one first. And that one is going to return true, and true is going to make this one true right away without evaluating the following. Okay? So what I really meant to say over here is this option B here may still have null pointer exception when obj is null. Okay, and for A over here, it will avoid null pointer exception when obj is null, simply because we are checking that right away over here, right? So this is why I was talking about a short circuit evaluation, just to be sure. All right? Are we okay with this reasoning here? All right? And exercise for you. Exercise. I want you to combine these two. Combine 1 and 2 using conjunction. Ampersand, ampersand. Rather than using disjunction, it should be possible. Rather than specifying the error condition, like in disjunction, you're going to specify guarding condition. All right? Think about this one here. All right, exercise for you. All right. All right, let me now move on. All right. Okay, so that's the so if you can see this is the right order where we put the error condition first, so that one is okay. And the one we just went over was if we actually try to swap the order, in which case we're going to get obj equals null later, right? That's the question. In that way, we're actually going to get the null pointer exception exactly over here. Right? You can see here. All right. So let me just make an annotation one more time. So this one here is going to get null pointer exception if obj is null. All right. Okay. One more question, and then we should take a very short break. Okay, one more question. Now, I want you to look at line number 11 and line number 12. I'm going to highlight it. You can see we are calling the equals method here. Now, we got three possibilities. Either it can be the equals method from the object class. It can be the equals method from the person class, which we are overriding. Or it can be the equals method from the string class, which you guys also have been using in your labs. So there are three possibilities. So now, number one, the equals method is from the objects. Number two, the equals method is from the person. Number three, the equals method is from the string class. Now, one or two or three, when I talk about this equals here. Okay? Yeah, go ahead. Should be a string, right? How did you figure?
Even though we first have this user object, ultimately we're calling the string of the first name.
First name, yes, yes. That's pretty good. Yeah, there will be a similar or slightly complicated exercise a little bit later, but I think that's good. So the way to see this is, if I write this down here. So I got this dot first name dot equals and then something dot 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 over here, right? So let's analyze this. This should be corresponding to the current class, which is person. The first name over here should be corresponding to the attributes, which is string. So up to here, it should be a string. And then when we call the equals method, it should be with respect to the string. All right, that's how you figure out. And it could be more complicated later when we have array, but we'll get there a little bit later. All right, guys, any more questions about this? Still not too bad, right? Okay, let me see. The next one will be about person collector. I think that's great. Why don't we take a very short break by taking attendance, and then we'll come back to do the final example. Let me stop the recording.